According to the National Electrical Code, the definition of exposed means that a conductive part is not permanently enclosed within the structure of a building. When considering iron girders and rafters that are not permanently enclosed within the building structure and are accessible from the interior of the building, even through a drop ceiling, these are generally considered exposed. Now let's address whether the structural metal is likely to become energized. Section 250.104 C of the National Electrical Code requires bonding of structural metal that is likely to become energized. Bonding involves electrically connecting the structural metal to the electrical grounding system. The purpose of this is to ensure that if the structural metal becomes energized due to a fault, the fault current will be cleared quickly and safely, minimizing the risk of electrical shock or fire. However, if there is no equipment attached to the structural metal and there is no roof access from the inside of the building, the likelihood of the structural metal becoming energized is significantly reduced. Analyzing whether these iron girders and rafters need to be bonded, several factors must be considered. Firstly, the code definition of exposed indicates that if the metal is not permanently enclosed and is accessible, it is considered exposed. Secondly, the requirement for bonding arises if the structural metal is likely to become energized. And thirdly, if there is no equipment attached to the metal and no easy access that could lead to accidental energization, the necessity for bonding is less apparent. Based on these considerations, it may not be strictly necessary to bond the iron girders and rafters. They are not directly exposed to personnel, reducing the risk of accidental contact, and they are not likely to become energized under normal circumstances. However, it is important to note that this analysis is based on the information provided and the general interpretation of the NEC. The final decision on whether to bond the structural metal should be made by a qualified electrician who can assess the specific circumstances of the installation and ensure compliance with all applicable codes and regulations. Bonding is a critical safety measure in electrical installations, and it is essential to understand the requirements and implications of the NEC. In situations where there is any doubt about the need for bonding, it is always best to err on the side of caution and consult with a qualified electrician. They can provide expert advice and ensure that the installation is safe and compliant. Furthermore, local codes and regulations may have additional requirements that must be considered. Electrical codes are constantly evolving to address new technologies and safety concerns. Staying up to date with the latest revisions of the NEC and any local amendments is crucial for ensuring the safety and compliance of electrical installations. To summarize, the decision of whether to bond structural metal in a building requires a careful analysis of several factors. Firstly, the definition of exposed in the NEC must be considered. Secondly, the likelihood of the metal becoming energized must be assessed. And thirdly, the advice of a qualified electrician should be sought to ensure compliance with all applicable codes and regulations. Consider the building's purpose and use. For example, a manufacturing facility where machinery is directly attached to the building's structural members might require more extensive grounding and bonding than a simple office building. Also consider the potential for future modifications or additions. If there is a possibility that equipment may be attached to the structural metal in the future, it may be prudent to bond the metal now to avoid the need for costly retrofitting later. Think about the building's location and environmental conditions. Buildings located in areas with high lightning activity or corrosive environments may require additional grounding and bonding measures to protect against electrical hazards and corrosion. It is also a good practice to document all grounding and bonding decisions and installations. This documentation can be helpful for future inspections and maintenance and can provide valuable information for troubleshooting electrical problems. Remember that grounding and bonding are not one-size-fits-all solutions. The specific requirements will vary depending on the building's design, construction, and use. Understanding the principles of grounding and bonding is essential for ensuring the safety and reliability of electrical systems. By following the guidelines in the NEC and consulting with qualified professionals, you can create a safe and compliant electrical installation. The National Electrical Code provides comprehensive guidelines for electrical installations. including specific requirements for grounding and bonding. Section 250 of the NEC covers grounding and bonding in detail, and it is essential to consult this section for specific requirements and recommendations. In addition to the NEC, there may be local codes and regulations that apply to electrical installations in your area. These local codes may be more stringent than the NEC, and it is important to be aware of them and comply with them. Regular inspections and maintenance are essential for ensuring the continued safety and reliability of electrical systems. Electrical systems should be inspected regularly by a qualified electrician to identify and correct any potential problems. Also, it is important to train building occupants and maintenance personnel about electrical safety. They should be aware of the potential hazards associated with electricity and know how to respond to electrical emergencies. Electrical safety is everyone's responsibility, and it is essential to take steps to protect yourself and others from electrical hazards. By following the guidelines in the NEC, consulting with qualified professionals, and promoting electrical safety awareness, you can create a safe and reliable electrical environment. Furthermore, consider that advances in technology and construction practices may lead to changes in the NEC and other electrical codes. Staying informed about these changes is essential for ensuring that electrical installations are up to date and compliant with the latest standards. Joining professional organizations and attending industry events can be valuable for staying informed about the latest developments in electrical safety and technology. These organizations often offer training programs and educational resources to help electricians and other professionals stay up to date. In conclusion, the decision of whether to bond structural metal in a building is a complex one that requires careful consideration of several factors. By understanding the principles of grounding and bonding, consulting with qualified professionals, and staying informed about the latest codes and regulations, you can ensure the safety and reliability of electrical installations. It is important to prioritize electrical safety in all aspects of building design, construction, and maintenance. Electrical hazards can have serious consequences, and it is essential to take steps to protect yourself and others from these hazards. Remember that electrical safety is not just the responsibility of electricians and other electrical professionals. Everyone has a role to play in promoting electrical safety awareness and preventing electrical accidents. By working together, we can create a safer and more reliable electrical environment for everyone. The goal of bonding and grounding is to create a low impedance path for fault current to flow back to the source. This low impedance path helps to ensure that overcurrent protection devices, such as circuit breakers or fuses, will operate quickly to clear the fault. If the fault current is not cleared quickly, it can cause overheating, arcing, and potentially fire. Properly bonded and grounded electrical systems are essential for protecting people and property from electrical hazards. Additionally, consider the type of electrical equipment that will be installed in the building. Equipment that is more sensitive to voltage fluctuations or electrical noise may require more robust grounding and bonding systems. The NEC provides specific requirements for grounding and bonding different types of electrical equipment. It is important to consult these requirements to ensure that the equipment is properly protected. Also consider the potential for electromagnetic interference or EMI. EMI can disrupt the operation of electronic equipment and can even cause damage. Properly grounded and bonded electrical systems can help to reduce EMI and improve the performance of electronic equipment. There are several different methods that can be used to bond structural metal. One common method is to use bonding jumpers, which are short lengths of wire that are used to connect the metal to the grounding system. Another method is to use grounding electrodes, which are metal rods or plates that are buried in the earth and connected to the grounding system. The choice of bonding method will depend on the specific application and the requirements of the NEC. In addition to structural metal, other metal components in the building may also need to be bonded, such as metal piping, metal ductwork, and metal enclosures. The NEC provides specific requirements for bonding these types of metal components. Understanding these requirements is essential for ensuring the safety and compliance of electrical installations. Proper documentation of the grounding and bonding system is essential for future maintenance and troubleshooting. The documentation should include a detailed description of the grounding and bonding system, including the location of all grounding electrodes, bonding jumpers, and other grounding and bonding components. The documentation should also include a record of all inspections and tests of the grounding and bonding system. Regular inspections and testing of the grounding and bonding system are essential for ensuring that it is functioning properly. The inspection should be performed by a qualified electrician and should include a visual inspection of all grounding and bonding component. The testing should include measurements of the impedance of the grounding system to ensure that it is within acceptable limits. Remember that electrical safety is an ongoing process. It is not enough to simply install a grounding and bonding system and then forget about it. Regular inspections, testing, and maintenance are essential for ensuring that the system continues to function properly and protect people and property from electrical hazards. Furthermore, be aware of the potential for changes in the electrical system over time. Modifications, additions, or renovations to the building may require changes to the grounding and bonding system. It is important to consult with a qualified electrician before making any changes to the electrical system to ensure that the grounding and bonding system is still adequate. Also, be aware of the potential for environmental factors to affect the grounding and bonding system. Corrosion, moisture, and other environmental factors can degrade the performance of the grounding and bonding system over time. Regular inspections and maintenance can help to identify and correct any problems caused by environmental factors. Always prioritize safety when working with electrical systems. Electricity can be dangerous, and it is important to take precautions to protect yourself and others from electrical hazards. If you are not qualified to work on electrical systems, do not attempt to do so. Hire a qualified electrician to perform any electrical work. In conclusion, the decision of whether to bond structural metal in a building requires careful consideration of several factors, including the definition of exposed in the NEC, the likelihood of the metal becoming energized, and the advice of a qualified electrician. By understanding the principles of grounding and bonding, consulting with qualified professionals, and staying informed about the latest codes and regulations, you can ensure the safety and reliability of electrical installations. Here are some additional considerations when evaluating the need for bonding structural metal. Firstly, consider the occupancy of the building. Buildings with sensitive electronic equipment or critical operations may benefit from more extensive bonding to minimize electrical noise and ensure reliable operation. Secondly, assess the potential for lightning strikes. Buildings in areas with high lightning activity may require additional grounding and bonding to protect against lightning surges. Thirdly, evaluate the presence of other metallic systems in the building. Interconnecting metallic systems such as plumbing and HVAC can create unintended current paths and increase the risk of electrical shock. Bonding these systems together can help to minimize these risks. Fourthly, consider the use of surge protective devices or SPD. SPD are designed to protect electronic equipment from voltage surges, but they rely on a properly grounded and bonded electrical system to function effectively. Fifthly, review the manufacturer's instructions for electrical equipment. Some equipment may have specific grounding and bonding requirements that must be followed. Sixthly, consult with a qualified electrical engineer. An electrical engineer can perform a detailed analysis of the building's electrical system and recommend the appropriate grounding and bonding measures. Seventhly, consider the cost of bonding. While bonding is an important safety measure, it can also be expensive. It is important to weigh the cost of bonding against the potential benefits. Eighthly, document all grounding and bonding decisions. This documentation can be helpful for future inspections and maintenance and can provide valuable information for troubleshooting electrical problems. Ninthly, regularly inspect and test the grounding and bonding system. This will help to ensure that the system is functioning properly and that any problems are identified and corrected promptly. And tenthly, stay up to date on the latest codes and standards. Electrical codes and standards are constantly evolving, so it is important to stay informed about the latest changes. In addition to the above considerations, it is also important to understand the different types of grounding and bonding systems. There are several different types of grounding and bonding systems, each with its own advantages and disadvantages. The choice of grounding and bonding system will depend on the specific application and the requirements of the NEC. Here are some of the most common types of grounding and bonding systems. Firstly, the equipment grounding system. The equipment grounding system is designed to provide a low impedance path for fault current to flow back to the source. This helps to ensure that overcurrent protection devices will operate quickly to clear the fault. Secondly, the bonding system. The bonding system is designed to connect all metal parts of the electrical system together to create a common ground potential. This helps to reduce the risk of electrical shock. Thirdly, the grounding electrode system. The grounding electrode system is designed to connect the electrical system to the earth. This helps to stabilize the voltage of the electrical system and provide a path for lightning current to flow to the earth. Fourthly, the separately derived system grounding. Separately derived systems, such as generators and transformers, require their own grounding system. The grounding system for a separately derived system must be installed in accordance with the NEC. Fifthly, the intrinsically safe grounding. Intrinsically safe circuits are designed to prevent explosions in hazardous locations. The grounding system for an intrinsically safe circuit must be installed in accordance with the NEC. Sixthly, the lightning protection grounding. Lightning protection systems are designed to protect buildings from lightning strikes. The grounding system for a lightning protection system must be installed in accordance with the NEC. Seventhly, the data center grounding. Data centers require special grounding systems to protect sensitive electronic equipment from electrical noise and voltage fluctuations. Eighthly, the healthcare facility grounding. Healthcare facilities require special grounding systems to protect patients and staff from electrical shock. Ninthly, the industrial facility grounding. Industrial facilities require robust grounding systems to protect equipment and personnel from electrical hazards. Tenthly, the residential grounding. Residential grounding systems are designed to protect homeowners from electrical shock. Each of these systems has its specific purpose and requirements under the National Electrical Code. Understanding these distinctions is key to proper system design and implementation.